So here are the solutions for the quiz that you took. We're going to start out, or the first problem is a 24-kilogram child descends a 5-meter high slide and reaches the ground with a speed of 2.8 meters per second. So the first thing is to do a bar graph analysis for this situation. And so we look at the before situation, which is right here, and does the child have kinetic? And the answer is no. How do you know that? Because there are no whooshies. All right, the second thing is, does the child have gravitational potential? And the answer is yes. How do you know that? Because h equals 5 meters. The third one, does the child on the top of the hill have elastic potential? And the answer is no. How do you know that? Sorry, because there's no spring. And so the only type of energy that we have is EG, and I'm going to draw 4 bars. It doesn't really matter how many bars you draw, as long as you draw at least 2 bars. All right, let's do the final situation. Does the child have kinetic energy? Yes. How do you know that? Because 1, there are whooshies, and 2, velocity is 2.8 meters per second. So we know that we have some K. I don't know how much K yet, so I'm just going to draw like 3 bars without a top on it. Does the child have gravitational? The answer is no. How do you know that? Well, it says h equals 0, and the child is right at the h equals 0 sign, so there's no gravitational potential. Does the child have elastic energy? Nope. No elastic energy. How do you know that? Because there's no spring. Does the child have thermal? Well, it might. Let's keep reading. Generally, we would say no, but we look at part B, how much energy was transferred to the thermal account due to friction in the process. That tells us there was energy in the thermal account. And so, because that's literally what's being asked for. So, it doesn't really matter how many bars you put in each one. It's just we only have EG at the beginning, and then we have EK and ETH at the end. So that was 3 points. 3 bars, 3 points. Or 3 types of accounts, 3 points. How much energy was transferred to the thermal account? So now we want to write down our equations. So we know that we have mgh is my initial, and then I've got 1/2 mv squared plus ETH. I haven't really given you a formula for ETH, but lots of times I have shown you just doing ETH, and what we're trying to solve for is ETH. You got 1 point for writing this equation down. Now, when I went over this on Monday, I said there are 3 parts to having a correct solution. The first one was writing down the equations in variable form. The next one is substituting in the values. So we're going to start at the left. What was the mass of the child? It was 24 kilograms. I know that G is 10 newtons per kilogram. You could also put meters per second squared. And H is 5 meters. That's everything on the left. On the right, we've got 1/2. M, what is M? Still 24 kilograms. What is V? 2.8 meters per second. And I need to remember to square it. And then ETH is what we're looking for. I don't know what it is. That would earn you a 2nd point. Then you substitute in the values to get ETH equals your final answer. And I'm not going to take the time to do that just because I have people who have not taken the quiz, but basically you are going to find this value and then subtract this from this value, and that will give you ETH in joules. Number 2. So a dart gun vertically launches a 25-gram dart 50 centimeters high. So we want to do some kind of before. I've got a dart going upwards. If you Continue reading. Determine the minimum energy stored in the spring when the dart gun was loaded. So I told you there was a spring, so you can like imagine some kind of spring. And then if you want to draw the muzzle of the gun around it, that's fine, but that's what we've got. So I'm going to put this as my h equals 0. And I know v is equal to 0 because before you launch something, it is not moving. So that is my situation 1. I know that m is equal to 0.025 kilograms because I need to convert to kilograms. And then my final situation, my dart is up here. 5 centimeters high is the top. Once it reaches the top, the velocity is 0. And I know that h is 0.5 meters because, again, I need to convert to standard units of kilograms and meters. That didn't actually earn you any points, but that just to help you like figure out what we're doing. So in the beginning, initial state, is there kinetic? Nope, because before you launch, you are not moving. Is there gravitational? I did not put gravitational. I defined it as 0. You did not have to. I will not show you the math for that, but if you want to see it, you can. Was there elastic? Yes, because there was a spring mentioned in the problem. All right, in the final state, was there kinetic? No, because we are at the top of the trajectory. Was there gravitational? Yes, gravitational, because you have gone 50 centimeters high. Was there elastic? No, because we've already launched. Is there thermal? No mention of thermal, so I'm going to say no thermal, and so that means all of the elastic was converted to gravitational. So that earned you 2 points. I know I'm not defining my system. People define the system in various ways. I just always assume everything is in the system. I did like score if people didn't put things in the system and instead did work. I scored that individually. Okay, so 2 points, 2 bars. Next thing is the equation in variable form. 1/2 k x squared is equal to mgh. That earned you a point. I said that was a critical part of it. 1/2 kx squared, that is literally what I'm solving for, is the energy. So I'm just going to leave that the way it is. And then mgh. So what is m? It's 0.025 kilograms. G, 10 newtons per kilogram or meters per second squared. And then h is 0.5 meters. And so again, I calculate that. Whatever answer I get here is what I'm looking for. I'm not going to give you the answer because there are people who have not taken the quiz, but you solve for that, just simple math that you plug into it, and that is the correct answer.